We'll proceed flux in calculus. Calculating flux through a surface. Calculating flux through surface. This is what we are talking about. How to calculate flux through a surface. What is a flux? Flux is nothing but volume per second, rate of flow per unit of the time. That is called flux. So, if I have a surface, this consider this is a surface, and if this is a surface, and through this surface, if I have a water and it flows through the surface, then how much water it passes the surface volume of water per second. Now consider surface as a whole, so it's easy. Now I have a water. Consider that I am putting it inside a river. Water is flowing and I put inside this in a river. Water has velocity. How much water is passing through this hole or this surface per unit time? What is the meter cube? Meter cube volume that is passing through the surface per unit time. This is the flux of the water velocity vector field through this surface. Okay, so flux is nothing but, now we have talked lot about vector field. Vector field is nothing but algebraic vector. A vector has components and each component is numeric, then it is called a static vector. If I have a vector f, capital F equal to 2i plus 3j, then it is called a static vector. But if I have capital F vector equal to x plus yi plus x plus sine yj, then it is called algebraic vector in a way that each component is now again function over independent variable x and y. So if I keep changing x and y, I'll get different set of static vectors, numeric vector. It is called vector field. Like if water is flowing and this is considered, this is x-axis. From left to right, this is x-axis. Now minus x-axis, water is flowing toward positive x-axis. Consider the water velocity is xi. Water velocity is xi. If that is the case, then velocity is not, it is in direction I, that is true, but velocity is not constant. At the beginning, water velocity is 0 at the origin. As water is proceeding, then water velocity is growing. Actually, it should be minus xi, because from mountain, water falls, and something like if you proceed, then the speed will decrease. If I make xi, the way water is proceeding, its speed is also increasing xi. So if the vector is algebraic vector like xi, then it is called vector field. If it is passing through area, then speed, velocity into the area is the flux. So if it is x and area is y, the net flux is x into y. Meter per second is the speed, meter square is the area, then meter cube per second. That is the flux that is passing through this kind of this surface. So that is the concept of flux, calculating flux. If I have electric field, if I have electromagnetic field, if I have magnetic field through a surface, how much is the volume of magnetic field per second it is passing through? That is the flux of the magnetic field through this surface. Okay, so it is something like this. So consider that this example I give, consider my hand is a surface. So surface, if the velocity vector is vector field, surface, now it has perpendicular in this direction. If this is x-axis and surface is in yz plane, then it's perpendicular, then it's the surface can be oriented. Surface can be oriented. Oriented means that surface has two sides, one side, another side. One side is oriented in the sense that everywhere it looks similar, but other side everywhere it looks exactly different. Then it is called oriented surface. So if surface is oriented, then it has a direction. Okay. So if it has a direction, consider this surface, this side of the surface has direction like this along x-axis. If that is the case, then we can say that the net flux is velocity vector field dot area vector. Not only area, not only velocity, now vector. Because if velocity is like this, water velocity is like this, in this direction, how much is water passing through the surface? Then this dot product with this direction and multiplied by the area. So vector field dot product with the area field. Capital F dot A vector is nothing but the flux. Now, if vector field, if it is vector field algebraic vector, then it will come as integral calculus. So, capital F vector dot D. D will come into the picture if it is calculus. So, capital F vector dot dA vector. Now, this is the net flux integral over the full surface. Okay. So if this is a rectangular surface, if it is rectangular surface, then minus x to plus x, minus y to plus I, x direction, y direction. If that is the case, so that is the flux. Capital F vector, that is velocity vector, dot small d, capital A vector, integration, surface integration. Okay, surface integration. This is flux. Now we have not only this, now we understood that how to calculate the area vector. Now we understood that how to calculate area vector. The vector field anyway we will have. But if I have a surface, how to calculate area vector? Why area vector is required? Area vector in the sense area vector field. Because if this is the area, then area vector is nothing but, if area is 10 meter square, 10I perpendicular to this. So 10I. If this is x-axis, then if this is the plane, the 10I, that is the area. But if this surface, if I mold this surface like this, then area vector everywhere it is different. Now it comes as algebra. If it comes as algebra, then area vector calculation is difficult. Past two videos I have proved that how to calculate area vector. So if you want to calculate area vector, then you take any point on the area as position vector. If any coordinate point on this area, if there is a xy plane, if there is a xy, this is x-axis, this is y-axis, this is z-axis. So if this is xy plane, 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 then what about if this is xy plane and there is a surface like this, what is the area vector of the surface? Okay, so if I take any point here that is x, y, z as coordinate, then this is position vector xi plus yj plus zk. If that is the case, then x and y are independent variables. They are not dependent upon anyone, where z is dependent upon x and y. I can say z, that is the vertical. Z is nothing but function over x and y. Z equal to small f bracket x comma y bracket close. So that is the scenario. Now the position vector of any point, if this point coordinate is x comma y comma z, where z component is dependent component and x, y are independent component, or z component is dependent upon x and y. If that is the case, then position vector is x I plus yj plus zk. If I calculate gradient vector, if this is the position vector, then gradient vector will be perpendicular to it. If this is position vector, then gradient vector will be perpendicular to it. You can make rotation, whatever, but it will be in perpendicular plane. So if I have position vector p vector equal to xi plus yj, p vector equal to xi, p vector equal to xi plus yj, then dp by dx, gradient along x-axis, dp by dp by, okay, so dp by dx, if I calculate, if this is position vector and this is x axis, this is y axis, okay, dp by dx means if it is perpendicular, if this gradient is perpendicular, then what is I have showed it, okay. So if this is xy plane and plane is kept on xy plane, there is a plane, and if I move it up, this is xy plane, move it up and I tilt it. So earlier this is x axis, this is y axis. If that is the case, if I move it up and tilt it like this, keeping y constant, and then tilt it like this, keeping x constant, then I have dz by dx positive and dz by dy positive. So on the surface, this is x axis, this is y axis. So if I have a position vector, if I have, this is origin, this is x axis, this is y axis. If this is origin and this is the position vector, then if I do dp by dx, it will calculate the kind of gradient along x axis, gradient along x axis. If this is dp by dy, then it will calculate gradient along y axis, gradient along x axis, gradient along y axis. Gradient along x axis vector will be perpendicular to it. This direction will be perpendicular to it. Gradient, okay, so whatever gradient we calculate of a vector, gradient of a vector, then it will be found, it will be in a plane that will be perpendicular to it, straightforward. If I have a vector and if I calculate the gradient of this vector, then it will be a plane that will be perpendicular to it. So if I have dp by dx, dp by dy, then consider there are two vectors. dp by dx is one vector and dp by dy is another vector. Now if I do cross product of dp by dx and dp by dy, it will give me area. That area, that plane is perpendicular to this. If I have any two vector, if I calculate cross product, then it will give area between these two vectors. Now it will be a parallelogram. If it is like this, then it will give area of a rectangle between these two. If it is in same direction, then there is no area. So if I have a position vector and if I calculate gradient vector along x, dp by dx, okay, dp by dx, it will give me its gradient. Gradients mean tangent of this, that is perpendicular to this. Gradients with tangent of this means perpendicular to this, and dp by dy again tangent to this but in y direction. So if I have two vectors and if I calculate the cross product, it will give me one area. That area plane is perpendicular to this. This is what we are looking for. If I start from the beginning, consider this is the surface. This is the surface. Now surface I mold it. Now this becomes the surface. If this is the surface, I take out a small strip from the surface, that is delta A. Small delta A from the surface. Delta A, area region. It is that small that it is a flat region. If something becomes very infinitesimally small, then it will be a flat region. If I take out delta A and that delta A, if I zoom it, enlarge it, it becomes like this. If that is the case, it is lying somewhere, and then for any point xyz, if this is the position vector, then dp by dx, that is like this, dp by dy, it is like this. So dp by dx generally we signify with I vector. So if this is x axis, this is y axis, then dp by dx will be along I axis, dp by dy will be along j axis, dp by dx cross dp by dy, dp by dx cross dp by dy will give me area. But since it is an algebraic equation, so that will fall in this plane one, whatever plane we are talking about, because P where xi plus yj plus zk, z is dependent on x and y. So x and y is xy axis, but z will make it a curve. So dp by dx, even though it is along I axis and dp by dy, it is along j axis, but if I do cross product, it will result in an algebra, and that algebra, if I keep changing independent variable x and y, it will fall in this surface only with the area. This is what we talk. So we have now area vector, but it is a velocity vector. At the end, we calculated the gradient. If you want displacement area vector, then we have to do integration back. So dp by dx cross product dp by dy dA, A is xy plane. If it is Cartesian coordinate, it is dx dy. If it is polar coordinate, it is r d theta dr. If it is a spherical coordinate, then it is again r d theta dr, where r is a is the, if it is spherical coordinate, where a is the radius of the sphere. If I take a sphere and a is the small a is the radius of sphere, and if I have a vertical line, and at any moment this radius make phi angle from the vertical, then a sine phi is the r, and r will rotate in xy plane to 360 degree, 2 pi. So r d theta dr will transform into, similarly r will become a sine phi and d theta dr. So r is a sine phi a cos phi d phi. So this much it would change anyways. Now we have found that our flux calculation, capital F vector dot dA vector, that will integration along the surface. So capital F vector, that is velocity vector field, dot vector dot small d integration small d area vector. Now if I talk about area vector, now it is dp by dx cross dp by dy. D area, not D area vector. Vector has come as dp by dx cross dp by dy. dA is the xy plane. Now, if I have xi plus yj plus zk, if that is the case, then the cross product leads to minus dz by dxi minus dz by dyj minus dz by dxi minus dz by dyj plus k dA xy plane. Now capital F vector dot minus dz by dx I minus dz by dy j plus k dA xy plane, because we did cross product of the gradient. We want the position vector back from the velocity gradient vector. Gradient vector means velocity vector. So we are doing dA. Now the question arises is that through that, can I find surface area? If I am talking about surface area vector, that is minus dz by dxi vector minus dz by dyj vector plus k vector dA. If I want surface area, then the dA, the small surface, we have area vector. dA area vector is altogether minus dz by dxi vector minus dz by dyj vector plus k vector dxy plane. D is small d, that is integral calculus. Now, if I want surface area, this is area vector. If I want surface area, I have to calculate the magnitude of this vector. So, magnitude of this vector is square root of dz by dx whole square plus dz by dy whole square plus 1 whole square 1 dA. Now, the question arises, in the past video, we calculated surface area of a sphere in Cartesian coordinate and then in polar coordinate. Cartesian coordinate and then in polar coordinate. Interoperativity. From Cartesian coordinate, first we calculated a standalone. All these are our version. How to calculate area vector, where you have p position vector and then you calculate the gradient, and from there you calculate the cross product and then you integrate it. This is our version. You will not get in any of the book. Please support us. So our telephone number in India, that is +91, that is India code, +91, then 9483160610, +91, that is India country code. Telephone number is 9483160610. Whatever we are going to talk now, it is even exciting. Now, can I calculate the surface area of a sphere in cylindrical coordinate system? Surface area of a sphere in cylindrical coordinate system, not from Cartesian and then migrating from Cartesian to cylindrical, pure in cylindrical coordinate system. So that is the concept, that can we really calculate it. Okay, the surface area of a sphere. Now consider I have a sphere. Now consider that I have a sphere. Now how to calculate surface area of a sphere in cylindrical coordinate system? Now this is a cylinder. This is a cylinder. Now inside this cylinder I am going to put this sphere. How I can calculate the surface area of this sphere in cylindrical coordinate system? So that is the question. If this is a sphere and this is cylinder, then how I can calculate surface area of a cylinder, of a sphere in cylindrical coordinate system? So that is the question. Now, if I take cylindrical coordinate system, then at the base, when base is kept on xy plane, then it has a radius and it has theta angle. It has, this is a circular region. It has a radius and theta angle. Now it has height as z. So cylindrical coordinate system is a kind of function over r, theta and z. R, theta and z. R, theta and z, where xy plane equivalent, if x and y are two independent components, then equivalent of the independent component is here r and theta, whereas it has z component in xy, z component, then it is equivalent is z here also. So that is the scenario. Now I am talking about the surface area is dz by dx whole square plus dz by dy whole square plus 1 square root dxy plane. Now dz by dx will be replaced by dz by dr. Dz by dy will be replaced by dz by d theta. This is our version. You will not get anywhere. Plus 1 square root d xy plane. Now, how I can find z-axis as function of r and theta? That is a big question that is impossible to get. How you can find that? If you have a sphere, if you have a sphere, if you have a sphere, then consider this sphere is centered at the origin. This sphere, if this is x-axis, this is y-axis, then this is the origin. This origin enters into this sphere, and wherever the center of this sphere, there this origin is. So this sphere is centered at the origin. If that is the case, the half of, so upper hemisphere is, it is in two hemispheres. The upper hemisphere is above the xy plane, lower hemisphere is down the xy plane. Now, if that is the case, now the height of, consider this sphere has radius small a. This sphere has radius small a. Small a means if this is the radius, then on xy plane it will go into 360 degree. But it will go all around like Earth. It will go all around this radius. This radius is small a. If this radius is small a, then consider that any moment it is like this. If it is like this, if it is like this, then it is in xy plane. It is like this, then somewhere it is tilted. Now consider if I take radius as perpendicular, then it is equivalent to height what I am seeing from the xy plane. If I do radius like this, then it is the height what we are talking. The net height of this sphere is 2 into radius 2a. Now consider that I take any z value, any height, where if any height, if z equal to a, then it is full height. If z equal to 0, then it is xy plane. Now, if that is the case, then consider this is xy plane, and from center this is the z value, and if this is z value, then this is the, consider this is the radius. If this is the radius, then this is the z value. If this radius becomes like this, if radius becomes like this, it is bigger than z. This much height I have taken, where a sphere has this much full sphere. So if I radius is like this, then this is the height. Or if I say my height is this much I have taken, the radius is like this. Then what about, can you see, if I make a cross section here, it will bring a circle here also. This is our explanation. So if I make a cross section here, it will make a circle here also. If I make a cross section here, it will make a circle here also. If I make a cross section when z equal to 0, then it is xy plane. This is the maximum circle. If this z equal to complete a full, if I make circle, then it is a nothing, 0. So as we rotate this radius in perpendicular arc, then it will start making horizontal circles. What is this arc? If I consider this is the height z and this is the radius. Consider this line as r. This circle, this r is changing. If this like this, then r is very big. If it is like this, then r is small. Consider this is a variable r. Then what is the relationship between height a and r? R a square into r square equal to, sorry, the height square, z square into r square plus r square equal to the hypotenuse square. So z equal to a square minus r square. Got it? So now we are saying surface area. The surface area is nothing but square root of dz by dx whole square plus dz by dy whole square plus 1. Here xy is replaced by r and theta. So dz by dr whole square plus dz by d theta whole square plus 1 square root. Now z equal to a square root of a square minus r square. If I do by dr and then plus dz by d theta, so that is gone, there is no theta there, plus 1. So what is derivation of dz by dr? So derivation of square root of a square minus r square is minus r divided by square root of a square minus r square. That is whole square, dz by dr whole square in cylindrical coordinates. So it becomes like r square divided by a square minus r square plus 1 whole square. If I settle it down, then it becomes a by square root of a square minus r square. A by square root of a square minus r square. Dxy plane of the cylinder is nothing but r d theta dr. So please refer to our different coordinate system videos. So how coordinate system are formed. So if this is the base circle, then this, if circle is kept on the xy plane where a sphere is centered, where the sphere is kind of, where the sphere is centered at the origin. So half of the sphere is below the xy plane, half of the sphere is above the xy plane. If that is the case, if that is the case, then this portion that is kept on the xy plane, now this portion, the area dA, area is r d theta dr. R d theta means if I take a circle, then what is the length of this arc, full arc? If it is 2 pi, then it is r 2 pi. If it is theta, then it is r theta. That is arc multiplied by the radius, that will be the area. So multiplied by the radius for the small section of the area. For the small section of the area. So that will be r d theta into dr. R d theta into dr, that is a small strip if I take. Arc length is r d theta and this is dr. R d theta dr. I cannot multiply full because it is calculus now. It is not pure algebra. Algebraic calculus, because if I multiply, if this is the arc, that is the 2 pi r multiplied by r, that is the area, then it becomes 2 pi r square. Area is pi r square because area is varying. If I calculate the full area of a circle, then every moment area is decreasing if I take a small circle. So it is algebraic now. But for any r, where r is variable, at any r, if I take a small strip along the curve, then the curvature is r d theta and the length is dr. So r d theta dr. So now the integration is a by square root of a square minus r square r d theta dr. This is the surface area of the top hemisphere. If that is the case, then integration r is from 0 to a, and then theta is 2 pi. So it is now a by square root of a square minus r square r dr d theta. A I can keep outside. Then integration of 1 by square root of a square minus r square dr. 1 a if I keep outside, then r by square root of a square minus r square dr. What is the integration? This integration is minus a square root of a square minus r square. You can do differentiation. Then it will come back as r by square root of a square minus r square. So now integration is minus square root of a square minus r square. Now this integration lower limit is 0 to a. That is the full radius. A means 0. 0 means a minus a, lower limit. So minus plus a square. Now the integration is a square. Now d theta integration from 0 to 2 pi will be 2 pi. 2 pi a square is the surface area of the top hemisphere multiplied by 2, 4 pi a square. So 4 pi a square is the surface area of a sphere through the area vector and through cylindrical coordinate system. Okay, what is the anyway? Now let's proceed that what is the flux equation? Anyway, we deviated a little bit. What is the flux equation? Flux equation is capital F vector, that is the vector field, dot small d area vector. This is called surface integral. So capital F vector dot dA vector, surface integral over the full surface. Means if I am trying to consider that I had a flat surface and due to something it became molded and it became like this. It molded in a way that it became like this. Now earlier this was the surface. Earlier this was the surface. I'm sorry. Earlier this was the big surface, and surface I molded like this. Okay. Now, what is if I pass the water through the full surface area? What is the flux I can get? The surface was actually bigger, but it became like this. So, if this whatever the side you are seeing, actually this was big, but someone molded it like this. Then, if water is passing, then through all side, consider all side are holes. So from all side, the water will start emanating. It will go outside. Then what is the flux of this surface? This surface, what round you are seeing, this consider this is a hole. Like if this is the surface that looks close, equivalent is like this. So water is flowing through this surface. Like consider this surface and this surface. It is open. So if water is coming from here, then through this surface, how much is water coming out? Volume per second. That is water vector field capital F vector dot dA vector, where this full area, one area and this area, that I have to calculate A vector in terms of algebra. If I calculate whole, that is the flux. Okay. Now, if I follow Cartesian coordinate, then flux is capital F vector dot dA vector is now dz by dx minus dz by dxi minus dz by dyj plus k small dA. That is the, or it is called dx dy. So that is the calculation for the flux integral in Cartesian coordinate. What about cylindrical coordinate? If I have a cylinder, if I have a cylinder, then in that cylindrical coordinate system, if I have any surface, then through that surface, what is the flux? Okay. For cylindrical coordinate system, what we are trying to calculate? Capital F vector dot dA vector. Capital F vector dot dA vector. A vector. Consider in cylinder, there is a small a I have taken out. Small a I have taken out. If I take out a small a, then what is the area of the small a? If I take out small a, then what is the area of the small a? Small a area, if I take out a small a, that is the curvature into height. Curvature into height, that is r d theta dz. That is the area, r d theta dz. But this is not area vector. What is the vector of this area? Okay, if I take the plane down the line, then I have radius that is rotating in the plane. If that is the case, then any point if I take on the circumference, that is xi plus yj, that will be converted into, if a is the radius, a cos theta I plus a sin theta j. A cos theta I plus a sin theta j. What do you mean by a cos theta I plus a sin theta j? If this is the base of the cylinder and this is the origin, this is kept at the origin. If I take any point here on the circumference of the circle as x comma y, xi plus yj, then direction of the vector will be radial. Same thing you want, right? If I take any d area here, the direction of the area vector will be radial. What is this radial vector? So this radial vector is nothing but a sin theta I plus a cos theta I plus a sin theta j. What is the unit vector? Because a I have calculated r d theta dz. So unit vector will be divided by its magnitude, that is r. So cos theta I plus sin theta j is the unit vector. So now we have vector field capital F dot in bracket cos theta I plus sin theta j, that is a unit vector. Small d a vector is a, not a vector, a is r d theta dz. So this is the full equation for the flux integral in the cylindrical coordinate system. What about spherical coordinate system? Spherical coordinate system. Okay, I'll give the hint because it is too long discussion. So if I have a sphere and if I take a small area strip from here, then that will be dA. And then whatever is the perpendicular, this is the direction of the A. So direction of the A is radial from the origin, if center. If this is centered at the origin, then from origin if I calculate this, then it is the kind of radial vector. Okay, if that is the case, then what is A? What is the A? A is nothing on the surface. A is nothing but the vertical curve multiplied by the horizontal curve. That is the small a. So if vertical, if I make phi angle, if I make phi angle, then vertical curve is a, 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 vertical curve is a d phi, a d phi, whereas horizontal curve is a horizontal curve is a, not a. Okay, so if I take any strip here, I believe I have talked about it. So if, if this is a sphere, if this is a sphere, if this is a sphere, and if I take any strip, dA strip here, then it is not exactly top, it is not at the center, it is centered at the origin, it is at height z somewhere. If I slice it, it will make another circle with radius r. Okay, that radius r, what is the arc? That arc multiplied by the vertical arc, that is the dA. What is that r? If I have a radius of small a and making phi angle, then a, or if this is a and this is height z. Okay, if this is height z and this is a and this is r, then this is the phi angle it makes with the vertical. Then what is r? A sine theta, sine phi, a sine phi. So radius here, xy plane, the big radius is a of the sphere, but at height at, if I make a cross section, that radius is a sine phi, where sine phi is the angle it makes from the vertical, phi is the angle. So now what is the horizontal curve? So whatever is the r d theta, where r is a sine phi. So a sine phi, a sine a a sine phi d theta multiplied by a d phi, a sine phi d theta multiplied by a sine. So a square, that is the radius square of the sphere, a square sine phi d theta d phi is the dA. What about the perpendicular direction? If perpendicular direction, if I want the perpendicular direction from here, then from center, if I take any position here x, y, z, then it is xi plus yz plus zk. What is xi plus yz plus zk? What is x and y? If I make a cross section here, then there is a circle. X is whatever x is now, the, what is the radius of the circle? That is a sine phi. So a sine phi cos theta, a sine phi sine theta. These are x and y. What is z? A cos phi. So a sine phi cos theta I, that is the cross section x, a sine phi sine theta j plus a cos phi k. Now what is unit vector? A will go away. A will go away. Now it is sine phi cos theta I plus sine phi sine theta j plus cos phi k, and xy plane, and the area dA. dA is a square sine phi d phi d theta. So capital F vector dot sine phi cos theta I plus sine phi sine theta j plus cos phi k dA vector dA. So dA, this is the vector, unit vector. dA is nothing but a square sine phi d theta d phi. So that is the full expression of the flux, calculating flux of surface integral in a spherical coordinate system. So we will do some exercise and then we will proceed towards flux density. That's why I am in this chapter. Very powerful, very important. Flux density. Flux density, or called divergence. It will really divert someone's career. means it is that powerful. So that we will see. Please support us. +91 is the India country code 94831 60610. Okay, so we will see that.